Hello, my name is Ezzy.G. This first question's integral of sine cubed x times square root cosine x dx from written project 2. We instantly know that we can break this into the integral of sine squared x times square root cosine x dx. And we know that the trigonometric identity of sine squared x is equal to 1 minus cosine squared x. So we can now rewrite the integral as the integral of 1 minus cosine squared x times sine x times square root of cosine x dx. Furthermore, from here we know we can eventually do a u substitution for u equals cosine x, and du of this would be negative sine x. This allows us to replace all of the cosines and the sines within the function. So now it's rewritten as the integral of 1 minus u squared times u times du. And since this is technically negative du, a negative 1 will be pulled out towards the outside at the end. So now it's the integral of 1 minus u times u to the 1/2 times du. And here's where I'll pull out the negative for the negative du for the integral of u to the 1/2 minus u to the 3/2, distributing that u to the 1/2 to 1 and negative u. And so now we have the integral of u to the 1/2 du, so that we just know with the reverse power rule is going to be 2/3 the u to the 3/2. And the integral of negative u to the 3/2, same thing, using reverse power rule, du, we get negative 5/2, negative 2/5 actually, u to the 5/2. So now we can sub back in cosine x for u. So now we have the integral of sine cubed x times square root cosine x dx is equal to, that should be negative 2/3 cosine 3/2x plus 2/5 cosine x to the 5/2x plus the constant c. So now taking the integral of 1 over x squared times square root 4x plus 1 dx, we know we can use sub for u equals square root 4x plus 1, so u squared is going to equal 4x plus 1. It's going to equal u squared minus 1 over 4 is going to be x, that's our sub. 2u du equals 4 dx, so 1 over 2u du is going to equal dx, so we have the integral of 1 over 2u du over u squared minus 1 times 4 squared. U's are going to cancel, and we know 1 over 2, something over 16 is going to pull out as 8. So we're going to have the integral of 1 over u squared minus 1 squared. And we can expand that to u to the 4th minus u squared plus 1. And then we can factor that as u squared plus 1 squared times u squared minus 1 squared. And then we have a equals u squared plus 1 plus b equals u squared plus 1 squared plus c equals u squared minus 1 squared plus d equals u squared minus 1 squared. And then multiplying the denominator, we have 1 equals a times u plus 1 times u minus 1 squared plus b u minus 1 squared plus c u plus 1 squared times u minus 1 squared plus d u plus 1 squared. So putting in negative 1 for u, that gives us 4b equals 1, b equals 1/4. Putting in 1 for u equals 4d, so d is also a 4th. Now we have to set up a system of equations by matching up similar values together. We're really just putting together like terms here. So we get 1 equals u to the 3rd, a plus c, plus u squared, c plus 1/2, minus a plus u minus a minus c, plus a plus 1/2 minus c. So this gives us this following system of equations. And this automatically tells us that negative a equals c. Now, solving for this, we get the following system here as well. This basically tells us what terms go to what terms equal 0. So now we have negative 2c minus 1/2 equals 0, 0 equals 0, and 2c plus 1/2 equals 0. And this tells us that c actually equals 1. And a equals 1/4, and since we said a equals negative c, c equals negative 1/4. So now we have the following values here, and we can put that back into our fractions. So we have 8 times the integral of 1 over 4 u plus 1 plus 1 over 4 u plus 1 squared minus 1 over 4 u minus 1 plus u 4 u minus 1 squared. And now we can solve for each of these individually. So we have 8 times the integral of 1 over 4 times u plus 1 du plus the integral of 1 over 4 u plus 1 squared du minus the integral of 1 over 4 u minus 1 du plus the integral of 1 over 4 u minus 1 squared du. Now, notice the terms in these. They're almost identical except for the signs, which means that as long as we have the integral of the first two, we actually can then assume the integrals of the last two, just switching out for the signs. So if the integral of 1 over 4th u plus 1 du, we actually have to do a v sub now because we already used u. So v is going to equal u plus 1, dv is going to equal 1. So now we pull out 1/4 the constant. Integral 1 over v equals 1/4 ln v equals 1/4 ln u plus 1. And so now if we have that, then the other term, we can just assume that the integral of 1 over 4 times u minus 1 is just equal to 1/4 ln u minus 1. And if the integral of 1 over 4 times u plus 1 squared is equal to, we can just pull out, once again, 1/4 to that. 1/4 u plus 1 squared. Then we v sub that back in. V is u plus 1 again. dv is 1. So now we have 1/4 times the integral of 1 over v squared. Now we just use the reverse power rule once again. Now we get 1/4 minus 1 over u equals 1/4 minus 1 over u plus 1 equals negative 1 over 4 times u plus 1. So we can assume that since the integral of u over 4 times u minus 1 squared du is just going to be equal to negative 1 over 4 times u minus 1. Just notice the difference in signs. Now we try to plug everything back in, accounting for the difference in signs and accounting for that negative that we had to distribute earlier. And so accounting for just the u's right now, this is what we get. And now we have to sub everything back in, all the u terms back in for square root 4x plus 1. So now we can say that that original integral now equals 8 times 1/4 ln square root 4x plus 1 minus 1 over 4 square root x plus 1 plus 1 minus 1/4 ln absolute value square root 4x plus 1 minus 1 minus 1 over 4 square root 4x plus 1 minus 1 plus the constant c. And here's a video of me and a government ID, so you know I am who I say.